Hello, everyone. Thank you for attending this evening's presentation. My name is Buddy Burkhalter, and I'm a member of the 2030 Commitment Working Group of AIA Philly's Committee on the Environment. We are excited to welcome Timothy Locke of OPAL Architects to present What World Are We Building For? Exploring Ecological Boundaries Through Practice. We would also like to thank our sponsors at the silver level, One Click LCA, and at the bronze level, Interface, and University of Pennsylvania's Weitzman School of Design Center for Professional Learning. Having some technical difficulties. Okay, use the clicker. All right. Tim, do you think you can? I don't know what. I'll give it a shot. I've never done the presentation mode. Oh, there's the cursor. Okay, great. Thank you. The learning objectives for today are to understand multiple parameters for ecological systems, dynamics, and architectural design. Number two, understand the relative importance of embodied and operational emissions in architectural design and construction, and methods to improve both. Learn about new modes of practice which can reinforce decarbonized architectural design, and understand the purpose of circular thinking in architecture design. So our presenter today, Timothy Locke, is a registered architect and management partner of OPAL Architects, a nationally recognized mid-size architectural firm in Belfast, Maine. OPAL is an acknowledged leader in sustainable, ecological, and high-performance building design. In both institutional and residential project typologies, OPAL has a reputation for integrating technology and innovation with energy and material lifecycle modeling. Furthermore, in 2019, OPAL Architects was one of 27 firms nationwide that met and exceeded the carbon emissions reduction target of the 2030 commitment. In addition to his role at OPAL, Tim is heavily active in several AIA groups. He's on the board of directors for AIA Maine and a co-chair of AIA Maine's Committee on the Environment. He also sits on the National Strategic Council as Maine's representative, has served on numerous juries, and has chaired the AIA National Zero Carbon Working Group. In his role as strategic counselor, Tim provided support and guidance to the White House Climate Policy Office as they released their new White House definition for zero emissions, which was also announced at last year's Greenbuild. Tim has traveled specifically down to Philly for this event, so please join me in giving him a warm welcome to Tim Locke.
Okay, so we're going to do a little bit of a change here. Sorry. Give me a second. All right. Switching it up. Okay. Almost there. Okay. Can everybody see? And I'm hoping that the people on the Zoom can also see. I don't know any way to confirm that, but we'll just assume it's fine. Thank you so much for having me to Philly. Really excited to be here. It's a pretty quick trip down from Maine, thankfully, and I'm headed right back tonight, but it was great to spend the day here. It's a place that's near and dear to my heart. My wife grew up in Port Richmond. I learned that I asked her after we had lunch. And so it is a place we visit often, but it's great to be here in this context to share with you all today. What world are we building for is a question we ask ourselves a lot at our practice at OPAL. But I do like to always start with this motivational quote anytime we're speaking out to all of you, that the ultimate hidden truth of the world is that it's something that we make, and we could just as easily be made differently. And for us, what that means is it's about buildings. What if buildings improved our world instead of being these necessary distractions and detractions from it? And for us, starting our practice in Maine now, geez, what was it, 16 years ago, there was a kind of pretty obvious starting point for us. It's a far northern climate, 7,800 heating degree days a year, very little cooling, lots of solar radiation, and a pretty good electrical grid that didn't produce a lot of emissions. And so for us, when we were starting, leaning into passive house as a way to start the practice, found the practice, and have a kind of radical idea of rethinking how buildings could be done in this far northern climate was kind of a first stab at, answering that question about the potential for buildings to be made differently and improve our world. And they had some pretty significant material benefits for all of the kind of rural communities that we were serving at that time. We're doing only single family residential. And for a family that was looking at a new home, looking at a new building, and spending, upwards of $3,000–4,000 a year on heating, and taking up significant portions of their house with mechanical systems, and passive house is a really attractive option for them. And it became a really beneficial revenue stream for our practice. I'm not going to lie. I mean, that kind of risk-taking approach to commit to that paradigm really helped us. We started with a disadvances. Things are slow here. I've learned that the Zoom takes a little bit of time. Started with a really basic prototype. We actually got venture capital to build a passive house. This was the 12th passive house ever certified in the US. The first one in Maine, first one in all of New England. And, we took a kind of outside the box approach to doing it. It's not very often that architects seek venture capital as though we were a startup. This is how we did the first passive house. This was called the Go Home back when we were still called Geologic. We're not called that anymore. And that begat kind of long lineage of small passive house typology buildings across the coast of Maine, New England, and beyond. We were kind of focusing on single family at that time. And I'm gonna try to go faster if I can, but started to slowly adventure into kind of different typologies. This is a lab that we did for University of Chicago about 10 years ago. Started to look at institutional buildings, look at things that were a little bit more difficult, but still apply the same paradigm to it. The result of that, we can get to it. Slow slides, sorry. I'm really sorry about the lag here. I'm just trying to get it to catch up with where I am on my deck. You get to look at pretty pictures while we wait. Very sorry. Almost there. Okay, here we go. So the result of that body of work was kind of very consistent portfolio of very high performing buildings. So this is just every project that we have logged into AIA DDX between the founding of the practice, and I think it's 1 year behind 2022 reporting year. And across that project, all the green are those that were exceeding the current 2020 goal of 80% operational emissions reduction. And we look back at that portfolio and we're like, wow, it's great to have this tool, AIA providing that tool. We can look back and see that dedication, bringing passive house to literally every project we did, resulted in an average of 84% reduction across all of our projects. Really exciting. But it was just, we knew at that point, it was just the tip of the iceberg. We had to kind of expand into other territories. And so about 5–6 years ago, 2017, we decided to take on full embodied emissions assessment in all of our projects. And could we take the same passive house approach of conservation to materials as well? And that kind of led us to a kind of turning point. This is about 24 months ago, where I sat down and thought to myself, we're taking this piecemeal. but are we really looking at the whole picture of how we, as designers, are managing our system boundary? So one of my senior project managers had just got done completing his MBA at Sloan at MIT. And he was all excited about systems dynamics. And I'm like, yeah, I wonder what we're doing on that as architects. Are we really kind of asserting control over the system that we have control over as in the design process for buildings? And I looked up this article that I try to read once every couple of years. It's a Donella Meadows article. She is a systems dynamics thinker, past at this point, has this amazing piece about places to intervene in a system. And she's looking at any system. She was environmentalist, but ranks these areas of areas to intervene in a system from the least effective to the most effective. So 12 being the least effective, all the way down to 1 being the most effective. And it immediately struck a chord with me because I was picking up on these lines of inquiry that I knew were not working. So number 12, I've highlighted a few of them here. Constants, parameters, and numbers such as subsidies, taxes, and standards. I was like, wow, we get frustrated all the time. Like, why aren't the codes better? Why aren't our laws more stringent so we can do better buildings? I'm like, oh, it takes a really long time to change laws and we have no control over it. That's why it's a low level place to intervene. Thinking about products, can't we have better products? Why do they have these amazing products in Europe that we can't get? Well, these are systems that are also outside our boundary. We have nothing we can do about a lot of those things. And then the other two, education, information flows. We do a good job of getting to conferences and lecturing and teaching each other, but that doesn't necessarily change the system that we're interacting with. And it certainly doesn't change number 5, the rules of the system, how people get rebates, negative and positive incentives. And I started realizing that the thing that was common to all of our practice in buildings, sorry, there we go, was that we were kind of operating in this other area where we were just deciding to do things differently without asking permission. We were changing the system and self-organizing it around these specific parameters like passive house or embodied emissions. And we were changing the goals of the system, like we were incentivizing ourselves to meet different targets than say the discipline itself was choosing. And it was changing the mindset of our practice. And so developing a series of insights around that, working against the intuition and expanding our umbrella. That was the goal that we had around this kind of line of thinking in the last 2 years. So I'm going to share these insights with you. There's 8 of them, doesn't take too long. First one is that our intuitions are often wrong. They're largely emotionally based. They still are great motivators, but first we need to ask ourselves, the insight is to ask ourselves what we actually know. And I think the big one when we think about COTE, think about climate action is this, save the planet. That is an intuition, that is not an insight. The planet is going to be just fine. The planet's gonna be okay. We're not gonna be fine, but the planet will be fine. So we need to think of ourselves as preservationists of humanity, of how we live on the planet, of the species that we interact with. The idea of saving the planet is a false intuition. And we know this because we occupy this very, very small blip in geologic time. Any geologist is going to tell you that the planet will be here regardless of whether we're here or not. And it got even more interesting. I started looking at some of these charts that we had, just referencing Maine specifically. I don't know if you can see my cursor, but this chart charts the sea level, the height of the sea level. Here's the current mean high water mark. And this is 13,000 years, this scale. So these numbers are in thousands of years. So humans have occupied the state that I live in, which is a coastal state, for 13,000 years. And the sea levels had some pretty radical changes in that time. And the reason we know this is because we've found human remains at these levels and remains of human intervention at these levels in archaeological digs. So My house currently, where I live now, is about 400 feet above sea level. Well, 13,000 years ago, it was almost underwater. We would have had coastal property 13,000 years ago. And we're really concerned about sea level rise, and we should be, because it affects us, it affects our habits, it affects the way we live. But we have to recognize that humans have lived through all of these conditions. Humans will continue to live through other conditions beyond where we are now. What we're trying to do is preserve that uncertainty. We're trying to deal with that uncertainty. So climate change is about uncertainty. It's not necessarily about an existential crisis. And so getting out of that mindset. All species on the planet need energy. Human evolution has allowed us the unique ability to harness and transform states of energy at scale. But until recently, only 100 years ago, just over 100 years ago, our population was directly tied to energy. So the amount of energy we could use dictated the amount of people we could support on the planet directly. And it wasn't until the invention of the gas-powered tractor or the fossil fuel tractor that we allowed ourselves to produce, to move more energy than was necessary for the population that we had. Allowed the population to explode and decoupled our population from our emissions and led to over emissions. So that's really what we're dealing with. That uncertainty is based on the habits of overproduction. So that led us to this insight that an organization, civilization can only be sustainable if our renewable resources are used no faster than they regenerate, if disruptive pollution and waste are emitted no faster than they're broken down, and renewable resources have a timeline, non-renewable resources have a timeline to no longer be used at all whatsoever, right? It's pretty basic. We got to use less stuff, period. You know, we have to draw that down, whatever it is. Whatever it is, it's energy, it's materials, no matter what. We're not great at that in the US. We use 5.1 Earth's worth of resources per person on average. We're not the worst. We're definitely not the worst. Not even close, but it's nowhere near that kind of one-to-one that we need to be at to be sustainable. I gotta hide this again. We exist in a dynamic relationship with the natural world. This is our ecosystem. So we have a habit, I think, especially in architecture. I think a lot of people know this picture, Loger's primitive hut, of tying ourselves really closely to humanities and thinking about architecture as a human intervention that's non-ecological, and then fretting about how ecological we can make our buildings. Well, we need to start thinking about them as part of our ecosystem. Our ecosystem is all this stuff. It's all drawn from natural resources. We're not harvesting other planets. And so thinking about these things as separate is really just about idealism versus materialism. We're trying to think about things as material at OPAL, always measure and calculate what those impacts are. And that definitely changes how we think about a building. What's the limit of a building? We used to think about buildings as ending at 4 walls, and I think many people still think about buildings that way. You know, it's pretty common now that we think about energy. Energy comes in, waste, heat, and emissions come out. I think that 20 years of work on energy has kind of cemented that as core to, I think, at least most people's understanding of what a building does. But that boundary is quite tight. The first thing, considering total emissions, we already talked about that, changed our model boundaries a little bit. Now materials were part of that equation. Waste and byproducts of those materials, be it through demolition or replacement, were also part of that equation. But we still didn't see that as kind of really holistic enough if we're thinking about just using less stuff. So we were trying to look for a full recognition beyond just emissions that all of our projects participate in. And we thought about energy, materials, water, the environment or ecosystem, and stakeholders, us. You know, we're part of the ecosystem too. Again, not editing us out. And those had different byproducts. So we had the waste and the materials. We also had water, wastewater, suspended materials, pollution, biodiversity loss, and community impact. And kind of started thinking about our system as these 5 boundaries. Once we'd established that, we were starting to really consider side effects pretty heavily. And again, there's no such thing as side effects, just the effects that are outside of our thinking at the moment. We tend to be humans, pretty good open loop thinkers. We can have a goal, we make decisions around the goal. that changes the state of the system that we're in. Closed loop thinking is a little bit beyond that. It's like what we kind of try to teach kids. It's like you do these things, you learn from that change in the state of the system, and it might make you make a different decision next time. But that's still not considering the side effects. Like, what are the things that happen because of this, the decisions you make that are outside of your control? Deal with that a lot if people are into life cycle analysis modeling or life cycle assessment modeling and relating that to energy. Like, how do those things push and pull on each other? How are they not kept separate? And then the thing that I like to think about a lot is the other agents. There's a mirror of this diagram. There's people that are acting on the same system, an adversary to you, right? And they have their own set of goals that they consider equally important, that have their own set of side effects. And I like to go through this all the time, like the 6 potential opponents. I've made up 6, I'm sure there's more, but I've categorized them as 6 to paradigm shifts. We've all been on this list. 100% we've all been on this list. I know I've been on this list. And it's important to just know that that's out there, because they're all that mirror side of those system dynamics. There's the deniers. They're the ones that are in the news. They have cultural hurdles and habitual hurdles to a shift to change. Resistant to change, there's plenty of people we know, practitioners. Their business as usual is working just fine for me for now. I'm not going to change. Hesitant to change, that's a fear response. Governance structures, folks interested in maintaining their power, and a change in that system might affect that. Stakeholder allies, those have a potential financial burden with the change. And then peer allies, this is the most interesting one in a group of architects or building professionals. We've all been peer allies to each other at one point or another, I'm sure, because of our own hierarchy of expertise, and trying to break those things down is really important, and understand that sometimes that's just an education and communication gap. And we don't want to use that list of potential adversaries to make an attribution error, to kind of start blaming other people in the system for things that we can control. And this is, I think, what's the power of design. You know, what has happened in architectural design that I think is like problematic is this kind of cyclical permission seeking, right? We have this process, this design process, and we're constantly going back and asking permission to do the thing that we know will be beneficial for a client, for a building, for a community. And all of those permission seekings are just an opportunity for no to happen, for that ally, for that adversary to stop something that could be beneficial. And I think design is the thing that can break through that, you know, changing the way something looks or feels in a way that becomes appealing and isn't then about permission seeking, but is about community building. We started doing this with just the 4 main certifications. Of course, there's others. Started taking all of those certifications. You deliberately cannot read this because I think it's insane, right? You have the 4 main certifications that we tend to deal with. So we have LEED, Living Building Challenge, Passive House, and Well Building. I just took all their criteria. I also took our most sustainably dedicated client, that's the College of the Atlantic, and we just sorted all of their criteria and their sustainability plans or certifications into categories. And it was like, this is wild. Like, if you were trying to permission seek on all these, you'd never get anything done. But you still have to model them, right? And I have to like manage all that data. And it got me thinking that, like, you know, we do all this modeling, but all our models are inherently wrong. Like, they're fake. They're virtual models of something that we think will happen. We do the best we can. But really what I had to get people to do was ignore that giant, messy periodic table of criteria and think about a mental model about using less and doing more, being more impactful by doing that. And then last year, Scientific American came out with this article that really, I was like, okay, this is what I've been thinking all along. I'm glad it was proved out, that education and showing people data through modeling, particularly about climate change, is the least effective motivator that there is. It's right up here, like by far. The most effective motivator was social comparison, social comparison. Cool factor. Well, shit, we're designers, right? Like, this is our superpower. We can make things cool. We need to lean into that regardless of how much data we know, right? Let's stop getting in this argument up here if we can exist down here. And I love this quote. that the role of the artist is to make the revolution irresistible. Like that is our job, right? If you are a climate activist architect, if you're concerned about the impact of our buildings, you have a tool to fix that because you design cool shit every day, and we can make that irresistible. So for us, it was about the modeling getting much, much simpler. We call this our Passive House plus process. I made that name up. Too many pluses, it's hard to say. But it's really simple, honestly. It's first saying step 0 is, should this thing even exist, or can it be reused or simplified? Do we need to be doing anything at all? And if the answer is no, let's not do it. Then we're going to document the system like we just talked about and model the impacts. We're going to reduce demand first and negative impacts. So all the bad stuff, we're going to make it as small as possible. Only then are we going to expand the supply. So the easy analogy here is use less energy before you put the PV on the building, right? Because you have much more effect of using less before you add more. Then we're going to measure and report even after the building's open and use that to improve the model, cycle it back through, and do that across as many things as we can. And so that allowed us to kind of like really break open the practice. We had changed our name to OPAL now 6 years ago, and we kind of immediately realized that even that, just an architectural practice founding around that, wasn't enough. So now we have 2 sister companies that grew across that to try to leverage that idea across everything that we would consider the domain of something that the architect could control. So we have OPAL, not just doing architecture, but doing holistic ecological consulting. We have Timber HP, making wood fiber insulation in Maine out of wood residuals coming out of Maine sawmills, or any sawmills in New England. We'll buy your chips, doesn't matter where. OPAL Build, which is doing mass timber component fabrication. So all of a sudden now we had a way to kind of leverage experience, control of systems across components, across materials, and across advocacy. I'm going to quickly just give a brief description of each, and then we'll look at a couple projects that synthesize those things together. First, starting with the holistic ecological consulting. So a lot of that's what I've been talking about already. You know, it started with just taking that mess of that periodic table. We put together a building ecology squad, which is not just me, but George, Gabe, Dan, Karina, and Julia. Thank you so much. Did so much work on this over the course of 18 months. And we started just by taking that crazy periodic table and sorting it into our 5 categories. So we saw those 5 categories of the streams coming into the building that we decided it's arbitrary, but we can make our own systems, right? And we sorted them into these 5 categories. Still too much, right? Then we broke them down into things that we actually thought the architect had direct control over on every project. Even this is too small. I'm not even going to read them because I'm like, I want this distilled into not just that, but things that actually have a design impact that I can see, so that it can be something that's appealing to an owner, right? To a client. And so that was our dimensions of building ecology. That's how we consult. We could consult around this framework that we developed internally. We sorted it from based on the scale of community affected. So at the top, habitable planet, because it affects the entire globe. All the way at the bottom, healthy community, because it affects your stakeholders and their immediate community. And what we found when we did this was the number of the cohorts, especially when we got into institutional projects, non-residential projects, larger projects, that found a way in through things that weren't building emissions, way up here in the top, was vast. Most people are coming in through the bottom, and that's fine. We know, all of us in this room probably, that these are interrelated. They didn't need to know that. It was a chance for them to learn something, and it was exciting for everybody. We sorted it into 3 key items on each category. As I said, that I wanted them to have direct, visible design impact, something you could see with a design response, so that there could be a social comparison, back to that idea of the cool factor. And then we just kind of like put it together in a way that was digestible and always kind of cluing in when it triggered another category. So if we're minimizing energy use and we're not using fossil fuels, then we're going to have cleaner air in the building, which is going to affect the community health part. So people could start learning how they were interconnected as we went through it. Habitable Planet was obviously the first one. It was the one we're most experienced with, and the one that's still hierarchically probably most critical with buildings, because 40% of all global emissions come from the things that we do. They're the byproduct of our scope 3 emissions as architects. Just relative, I always like to do this when we travel, understand the difference of climate, like understanding that changes everywhere we go. So when we're standing here in Philly, you have a much less aggressively cold climate than we do, but you do have more cooling, and you have a slightly dirtier by about a third energy profile. What it results in is a pretty similar, actually, opportunity, whether it's here or in Maine. Reducing operational emissions is a pretty significant way to reduce total emissions. Pennsylvania's is driven more by the way you produce energy. Ours is driven more by the need for energy, but they come out pretty close to each other in the end. So climate response is just staying comfortable, right? Like if we're standing outside in the cold, one way to stay comfortable is I can produce 240 watts an hour. I don't know if there's any other runners in the room, but I can read that now on apps or on my watch. I can tell that I'm warm. I can wear way less clothes if I'm outside. If I'm standing still, I'm going to be cold. But there's a pretty easy way to deal with that. We can all wear a passive house every day just by wearing the right jacket. That's that passive house. But if you continue to run, maybe you break your knee, maybe you're going to be pretty angry pretty quickly, and your body's going to break down. And basically throughout northern North America, that's what we've been asking our buildings to do. This here on the right, basically for all of modernity, that's what we've been doing ever since we decoupled energy from population. 100 years ago, we've been asking our buildings to do that. No wonder they break down and they have to get replaced. No wonder we're replacing our mechanical systems every 25 years. We also want to look at embodied emissions, of course, reduce what we can, focusing mainly on insulation, concrete, and steel, because they're the biggest contributors across most life cycle assessments. Looking very specifically about total emissions, trying to be inclusive and exhaustive. We've recently, in the last year or so, started adding modules to this, like refrigerants and mechanical systems, into our total emissions boundary on that habitable climate section. Circular resource is something that I've become really interested in lately as well. The benefits potentially in reducing emissions by being circular, by designing for adaptability, by sourcing buildings and products responsibly, and by tracing impacts. This comes largely out of the Ellen MacArthur Foundation thinking about circularity. But I love this little graphic. This is actually something that a colleague of mine at Rocky Mountain Institute shared with me when we did a lecture together a few months back, that I thought was just brilliant. It's like, how easy is it something to be circular, i.e. reused? And going up here, it's how similar each unit is to each other. And then the bottom, it's the number that are made. And it's no wonder that furniture and clothing is by far the most circular and the most cost-effective and potentially profitable to be circular, because we're all basically the same size. Like, yeah, there's very tall people and shorter people like myself, but we could all wear the same clothes and generally sit in the same chair. So it's really easy to reuse that stuff. Really hard to reuse, really expensive to reuse planes, because there's just not many of them, even though there's a lot, even though they're very similar. Buildings are kind of have the opposite problem. There's a fair amount of them, but they're all totally different. And they're really hard to be, to get into that kind of ease of circular economy. If we really want to be circular as designers, we're going to have to think really hard about the way we design. The reason I'm so interested in circularity right now is because it has the potential to change the design paradigm. If we have to start considering a past system boundary, so we had the typical life cycle assessment that goes from the inception of the building out to end of life. And I know there's some that don't even want to measure end of life even. They want it to really be tight. A life cycle analysis should end at A5 even. I've heard that comment made even last week at the White House. Well, people that are thinking circular are not only going all the way to the end of life, but they're already going back into a past life of a previous building and thinking about essentially, I mean, I'm not trying to be glib, a multiverse of buildings and imagining these multiple lifespans of buildings overlapping each other constantly. And it's really interesting because it's basically taking this thing that we all know as practitioners and turning it on its head to this thing where everything's interconnected. The demolition of a building can feed directly into the construction of another one. And when you start thinking about that way, to allow that to happen easily, some things start to trigger, like, you know, maybe we don't want bearing walls in buildings because that means we have to take them all the way down if we want to change the space. Maybe we want really regular and long spans as often as we possibly can because it makes things more flexible, which means the propensity for it being torn down is lower. New questions. We talk about water use, and also just our conceptions of what we think about as zero water. And are we actually doing that, or are we changing the dynamics of the hydrology of our regions in ways that we can't walk back from? Resilient ecosystems, we want to always limit the human-only footprint as much as possible. We've started calling it that. So that means it's not just the building that's human-only, but also like lawn is human-only, obviously driveways, things like that, and trying to minimize that as much as possible. We've had the luxury with some projects on the coast of Maine where we can do that. We can build buildings on tiny piers that don't actually affect the surface at all, and the biodiversity can stay much higher. That's not the case everywhere, and ecosystems are different everywhere, and that has to be kind of acknowledged. And then healthy community, that's the one I think most people know well, even as stakeholders, and they know what they want out of those buildings. We had an opportunity of doing a project, we'll look at it later, where their entire reason for doing the project was just about making their campus ADA accessible. And we were able to kind of do this kind of really confined building to make that happen and still meet their emissions goals as well. So we put this all together and we have a benchmarking tool. We built this in-house. It uses a lot of inputs and formulas from other tools. We're trying not and always reference that within our tool, like when people need to use other ones to fill it out, but uses it a way to set benchmarks for the office. And since Passive House had always set its goal of 80% energy reduction, we're like, can we get to 80% reduction in use across all 5 of those categories? I don't know yet. You know, we've only been doing this for about a year. So far, we haven't done a building yet that got to 80% in all 5 of them, but we'll try, just keep trying it. And then this also means advocating. It means being here today with you. It means working with the White House on policy. It means starting things just off the cuff. We started a Maine Mass Timber Collective just last month through our COTE chapter to try to raise the baseline standards of care for biogenic structures, not waiting for to be told that there's a set point by the industry, but setting it ourselves. So that's for consulting. We're also making wood fiber insulation. So we did a crazy thing like 6 years ago where we bought an old paper mill and we bought a bunch of wood fiber insulation making equipment from Germany in a plant that was closing down because they were transitioning to making MDF for IKEA. They'd gotten a big contract. Well, it turns out that you make wood fiber insulation the same way you make MDF, you just don't press it as hard. And it also turns out is that as we start to super insulate more and more buildings around the country, that people need a lot of insulation. And this became quite quickly a really exciting business proposition for a lot of investors. And all of a sudden, there we were trying to design a factory, which we learned immediately we should not be doing. We thought we could, and we can't. But the potential was huge in reducing that embodied carbon because the insulation products that are available on the market are quite high in embodied emissions, and there wasn't really any good, readily available and readily scalable biogenic solutions. You know, measuring A1 through A3 on embodied emissions, it's the only insulation product that can show a negative. We do include biogenic carbon. We go based on, we can talk about that after potentially. I know there's a lot of debate about whether it should be included or not. I think we would advocate that it should, not just because of timber HB, but for a lot of reasons. It's a waste product too, like it fits in with that circularity. So when a sawmill makes lumber out of a log, there's a lot of chips. We call them residuals. If they pile up at a sawmill, we have a lot of sawmills in Maine, it can shut that sawmill down in 3 days if no one buys them. No one's buying them for paper anymore, or very few people are. So if there's a waste stream that can put to good use and also store carbon in a building, that's a pretty exciting opportunity. And it helps us revise our forest economy. I really forget that I'm a little behind here. With decline of paper production, those wood baskets are kind of going unused, and we have different problems in different areas. In New England, the problem is what I said, it's the potential closure of family-owned sawmills. In the West Coast, the problem is topped trees that can't be used for lumber sitting in forests and starting forest fires. There's different problems in different regions. There's also untapped regions that don't have the forestry industry they once did. It's an exciting thing. This is our giant mill. This mill used to print the New York Times for New England, but has been closed for a long time. Turns out you don't need anywhere near as much space to put in a wood fiber plant. So we're not taking up a ton of it. Here's a view of the inside of the first production line kind of getting installed. And it allows us to create wall systems that can save considerable amounts of CO2 in A1 through A3 over mineral wool, which was the product that we'd been using most extensively before that. And we also created a mass timber component fabrication shop. So this is in Belfast as well. The insulation plant is in central Maine. Because as we started to realize that there was going to be this market for insulation and this extreme interest in biogenic materials for structure, mass timber, so CLT and glue lams, why not start a component shop that could combine the two? So this is only about 2.5 years old, 3 years old, but they've already erected a full CLT point-loaded building. That's this building here. We'll look at it later. They've also done an erection of a completely panelized all-wood wall system from a crane on a barge. This was a site that, we'll look at this building in a second, but it was inaccessible by road. It's a field research station with a flowing seawater lab in it. It is studying marine life that exists in this one location in Penobscot Bay in the entire world, specific type of scallop. And because of that, it's completely off-grid. The Science Foundation is completely off-grid, no cars. All their energy is produced on the island. And how do you build a building that way? Well, there's two ways. You can deliver a bunch of sticks to the shore and put it together with a screw gun, or you can fabricate all these panels in the shop and crane them into place. This took 2 weeks to do, put the entire thing together instead of a crew having to live on island the entire summer. So it saved them time. And they also got this kind of super cool CLT and mass timber all wood panel. So here's some roof panels going in. That's a 3.5-inch 3-ply CLT panel with 14 inches of wood fiber insulation laminated to it. The lamination's happening in the shop in Belfast, and then it gets craned into place by the crew. Wall panels, slightly less insulation, but essentially you're getting a passive house level building, all CLT, all wood. Simple building. We love simple buildings for case studies because there's a really good chance people actually do them. Like, don't try to break the wheel and also make the most complicated structure at the same time, because there's a high likelihood the building never gets built. So this all happened over last summer, and we had our ribbon cutting at the end of the summer. Governor Mills was there. It was very exciting because it was bringing all these industries that we see as the future of the New England economy together, even in this very, very simple building. It's not earth-shattering architecture, but it was a pretty audacious concept to try to pull off, and it was exciting to be part of that. They're outfitting the flowing seawater system this coming summer, and then it'll be a fully operational postdoctorate lab at that point. And out of that kind of case study, OPAL Build was able to develop their typical system, and now we can deliver these as kind of little standalone structures wherever. We don't install, we send the panels out, and people can put them together. All mass timber, all wood fiber. And we can also use it for other components, like, say, retrofit window installs for deep energy retrofits. There's a big need for that across the country, especially if we're looking to be more circular. And we need to be able to find ways to use carbon storing materials for those retrofits and not just put a lot of foam on our buildings. So then we get to synthesizing that. We want to synthesize all three of those approaches together into architecture, because I was telling Roshni beforehand, I'm still just an architect. I know it's like I like to think about these things, like to pretend to be a bit of a theorist now and then, but I still spend most of my day just doing architecture, and I love it. So I'm always interested in how do we take what we're learning and make it into something more. So I'm just going to share 3 projects quickly. The first is a school that we finished during the pandemic for the Waring School in Beverly, Mass, about 20 minutes outside of Boston. This is a school that came to us with this really serious problem. They had no space. They have this all-school meeting every day. It's a private high school. And they were stuffing their entire student body into this room. And there was so much CO2 buildup in the room that people were literally falling asleep. And they didn't even realize that that was the problem that they were trying to solve. They asked us to solve an ADA issue and that they really wanted to be the first certified passive house school in Massachusetts. And then we go to this meeting and we're seeing kids fall asleep in front of our eyes. Like, well, we're going to solve this problem with another method for you. You know, getting fresh air into the building, getting properly sized spaces are going to solve it for you. And so they had this like pretty significant grade issue, as I said, 11 feet between lower campus and upper campus. And the only way somebody, a wheelchair bound participant could get from the entry court to upper campus was literally be driven, even though it was probably only 150 feet horizontally from one location to the other. And some other, architect friends that they had in their area were like, what if you just built a building? Because I know you want to do this passive house, because I've heard that it's really good for passive houses to be cubes, as close as possible to cubes. And then you just build a really long bridge. And we're like, how in the heck is that equitable? How is that meeting any sort of healthy community to tell the cohort that you're trying to serve with this new building that they need to walk outside on this uncovered bridge in order to be accessible? And we're like, we'll get you your passive house and we'll let the building be the bridge and we'll figure it out. We'll figure out how to do it. It's not going to be a cube, but we've learned it doesn't have to be a cube all the time and we can still hit the number. And so we used the building as the bridge. The second floor of the building became the thing that got those participants from that lower court to the upper court, completely enclosed, completely covered, very easy, accessible. And we were able to kind of somehow still not totally sure how, get the energy levels down low enough to meet that passive house goal. The building had to be very contorted and convoluted to get around all the trees. We're trying to avoid a very restrictive covenant within Massachusetts about tree removal, which we fully supported, but it was also incredibly difficult. And so some of the building's angles and contortions were just about missing some very, very large eastern white pines. You can see them through the window actually right there. So the bridge extends out. We had to snake past through those trees. Somehow our builder was able to do that without damaging any of those trees, which is amazing. And we did this all for $325 a square foot too. So certified passive house, solve those problems, low cost, by investing in the parts of the building that they needed to make those things happen and not in other parts. Here you can kind of see back under the bridge here. You kind of see from these aerials are nice to see how that form takes shape to try to get it through those trees. You can see it kind of sculpting through there down to the lower court. And all of a sudden they could breathe in their all-school meeting room. They had this new room that was the right size, completely supplied with 100% fresh air, with full energy recovery, passive house certified ventilation system. And because we knew that this room always had to house the whole school, we didn't have to super increase the ventilation values either, because we could just move the ventilation from serving the classrooms to serving this room as the occupants move around the building. which was kind of an exciting thing to do, so they didn't have to end up with 2 duplicate systems. And the total, so we had a modeled site EUI on that building of 5.7 kpd per square foot per year. Typical educational EUI, geez, I don't know what it is, what the average is now, but probably around 70, 75 for K-12. And measured after 1 year, we always want to go back and make sure we're measuring it. After 1 year, we were at 8, so a little bit above, but still well below passive house threshold, which is what was our target. And we're still waiting on the final paperwork from Germany on the certification, but the design has been approved. There's a couple of construction details that they're still approving in Germany, but exciting project. The next one is one that we did for that client that I talked about that had literally the most aggressive sustainability standards I've ever seen. They basically did what we did. They took all those certifications and then didn't filter anything. They just put them all in their sustainability standards for buildings. And it was 9 pages long, 12-point font, 9 pages long as a list. And when we got that, they were like, you're going to have to go to our sustainability committee and show that you're meeting all these throughout the project. And I said, okay, well, some of these, I got into it with them a little bit, but we were kind of pretty into it. This is a project that we did collaboratively, myself and Susie Rodriguez out of New York, formerly of Eniad. So we worked on it together. It was an amazing collaboration, probably one of the best that I've ever done, where really sharing our skill sets together. And we really wanted to do an all-wood structure for them there. And this was way back in 2018. We couldn't source full CLT, but we could do glulam's, and we could do the full wood wall system like we'd looked at earlier. They also had, these really aggressive standards around habitat. So they were an early case study project for Ornolux bird safe glass. So that's throughout the project. They also had really, really aggressive stormwater standards, which you can't even see, but it was amazing. There's no public stormwater in Bar Harbor, so we had to deal with that no matter what. But it was an exciting challenge. The other big thing with this project is they had 2 rooms that go above hospital level in air changes per hour. So they have a marine mammal dissection lab right here. Hospitals, usually we're looking at neighborhood of 6 to 7 air changes per hour. Marine mammals, because of the potential pathogens and dead mammals, is 12 air changes per hour. And so when we saw that, we needed a system that could ramp that high up and still serve general classrooms, because they also had like drawing studio in here that has just a normal open classroom. They had a GIS lab, just a bunch of computers. And they also had a printmaking studio, which also had chemicals, very high air changes per hour. So we needed a system that could do all that and still do it at passive house level, because that was their goal for energy use. When we did the modeling, the ventilation system alone was 40% of their energy loss. Usually, even in 100% fresh outdoor air, we're in the neighborhood of like 25, 30%. This was huge, so enormous. And so we worked with a mechanical engineer. This was Van Zelm out of Connecticut, custom designed that giant DOAS ERV, custom designed the enthalpy wheel to try to get something that could be efficient in all those different modulations. The bird safe glazing was a really exciting product to start to use as well. We've now looked at that on a couple projects with them. We'll see a different version of that later. And getting a commercial contractor used to building a school building all wood at this scale was a pretty significant challenge as well. And something that I think eventually they got into, but at first they were, I think, pretty wary of not having a steel erector on site at all. Just some images of the building. This is that printmaking studio that, again, is super high air changes per hour. There's this really interesting conversation we had with the professor that runs the printmaking studio, where she said, I really need a vent above the vats where I'm using my chemicals. And that's right here. You can see that in the photo. We're like, trust me, the amount of air that you're taking out of this room is already high enough. You don't need a vent right at the tanks, and you don't need it to go outside. We want to use that heat. We want to temper it, filter it, and use it to heat the rest of the building. She's like, no, I know I need it. I know I need it. So what we did was we just took one of the return air ducts and custom built a little hood. It still goes into the ERV, but now there's a boost switch that she feels like she can hear that the fan's going higher. And so everybody was happy. It was great. But, just some views down the hallway, again, trying to lean into the wood wherever we can on the project. This, all these stools were made by the college president from a white pine that had to get removed during construction. And he hand carved the names of all the donors and myself and Susie into each one of the stools. So everybody has their stool in the building. That helped make the building such a really nice thing, kind of cool little side thing. This, I think, is like the nicest bathroom in Maine. If you're ever in Bar Harbor, you can send me an email and we can go look at it. It's really nice. And we were able to hit their targets on EUI. Their goal was 24 kBtu per square foot per year. We got it to 11. That was in the modeling. And we were able to present it in a way that was really exciting to them. We were converting all the deferred carbon and the embodied emissions and the operational emissions into these units of measure, including this one at the bottom. They drive this night bus to and from town, Bar Harbor. It's about a mile away because some of the kids live in rental apartments there. And the first meeting we had on campus, we had to go to their all college meetings every time we presented. And anybody can speak. It's like, here's a picture of it here. They use the rules of New England town meetings. So literally any student, staff member, faculty member, administration member can speak as equals in this meeting. They're having this long debate about the night bus, about whether they should buy an electrified night bus. And what we were able to show them is like, you can do that. It's great, you should. But also, by the way, the deferred emissions would allow you to run the same night bus you have for 355 years. So maybe let's consider where we're putting our investment. And that was a fun day for them. Again, we try to measure this one as well. This one actually has come in after a year of operations under our model, the EUI, so we're 10 kBtu per square foot per year on an academic building that has collegiate labs, collegiate printmaking, chemistry lab, zoology lab within the building. So this is a real lesson for us that, those passive house approaches are possible. Those low embodied emissions are possible in any building type, no matter what convention is. So last one I'm going to share is a second building that we're just finishing now for College of the Atlantic that I call it Lifespan. It's a dorm. And right after we finished that building, literally a week after, we did the ribbon cutting at Convocation. This was in 2021 for the building you just saw. College president calls me, and it's like, I don't know, if those of you who do residential architecture, sometimes you have a client that gets done with their project and they just want to do another project because they just love it. They just love doing it. And Darren calls me, he's like, I want to do another building. And I'm like, really? Like, we just finished. He's like, yeah, but I want to do all the things we couldn't do in the other one because we couldn't buy the stuff yet. And I was like, all right, let's do it. This one wasn't a collaboration, and it was on this like crazy tight site. The interesting thing about College of the Atlantic is that it's 8 old vacation properties from the turn of the century, the turn of the 1900s that they bought. And so there's all these kind of footprints of the buildings that used to be and the kind of outbuildings and accessory bits of human imprint that used to be. And the site that they chose was completely within a tennis court that used to be there. So the ground had been leveled, previously disturbed site. And the challenge was, can you fit this entire building within the limits of that old tennis court? And you could only see the residuals of it, right? They weren't still playing tennis there. It's from 100 years ago. So it's a very compact building, but it allowed us to try something pretty interesting that I was interested in around creating a building that could potentially see another life as a non-residential building. They wanted to do all mass timber. Unlike the other one that was a hybrid, they wanted to go full CLT on this. And so we developed a layout that would be conducive to potential reuse, no bearing walls, all glue lamp posts with CLT spanning across multiple bays. Obviously, dormitory typology is really conducive for that, but I wanted the potential for all those walls to at some point be knocked down, the demising walls, and be able to use the building as something else if you had to. So CLT was like about thinking about Maison Domino, but with glue lambs and CLT. That was kind of what I was trying to instill into our structural engineer, Thornton Tomasetti, structural engineer for this. And we're kind of inventing a lot of these fasteners because if any of you have done mass timber projects, you know that we're kind of at toddler phase right now. Everybody wants to do it. It's on every project. It's so popular. A lot of these details don't exist. Like even for basic layouts, like this is the most basic glue lamb layout that you could possibly do. If this is the steel building, I'm sure that they could have detailed it in a week, but all of these details had to be custom drawn, custom fabricated. This is the hurdle for mass timber. So everybody who's super excited here about mass timber, understand that. And it is in the process of getting built into your cost, trust me. It's an issue. Even with insurance, people are getting wise to this being a fad, so warning. So here's our layout. As I said, OPAL Build did the erection of this building. So we tried to go out to other competitors. The only people that even responded to the ask from the construction manager to install the CLT were steel fabricators, and then all of them disappeared when they actually needed to provide a proposal. So only OPAL Build was able to do it in our region. And they put this entire building up in 3 weeks. So mass timber came from Austria, in this case, KLH, got delivered in shipping containers. The erection of the mass timber took 3 weeks to top out. It's a 3-story building. They spent another 3 weeks on site just installing the roof trusses. So that's the difference between these types of large systems that can be craned into place versus the way we typically think of wood construction. Here's the crew. Special shout out to Dave Miller, who's our site super. And then hopefully this video will play. We'll see what happens. This is Darren. I don't know if it's going to play. No, it's not going to play. He even came on site and he helped them nail in base plates on the CLT. So when you have a college president that's willing to do that, you know, it's a good client for sure. All wood fiber insulation. In this case, because Timber HP had made it a certain way down their production, the build out of their production line, we're able to use Timber HP in this building. So all the blown in insulation in the wall cavity is wood fiber insulation from Timber HP. The rigid board, which will be available from Timber HP later this summer, is from our German partner, who's also an investment partner in the factory project. But all wood fiber had this nice burnt umber look for a while. And we had to invent a bunch of deflection details for wood, which don't exist either. Big delegated design bill in the middle of the project, which takes a client that's like really invested in those types of case studies in order to achieve. We also always want to go back and measure, as we do, and almost done. So we typically, you know, start, and I'm sure a lot of you do too with your life cycle assessments, we're going to look at just the construction assemblies. And what we found out quite quickly is that if we're looking at an all mass timber building, you can see that red dashed line, that's the negative that we're achieving through biogenic reduction in module A, is still at a stage where it's completely offset by the deconstruction, that's module C of the building, and the lack of availability to send that material into another life cycle in module D. So we're still kind of, again, toddler phase with these materials. Like in order for this to actually become zero carbon, I would say that we need a aftermarket use like we have for steel or concrete for wood. We don't really have that now. 86% of wood gets incinerated or landfilled, not reused. So that's why you get these kind of bigger chunks in those modules. And we were surprised, I had the structural engineer actually design a CLT and steel hybrid and a steel T and concrete structure as well, because I just wanted to model them against each other. And the total savings of the all mass timber building to the steel and concrete building wasn't huge. It was about 40,000 kg CO2. And in that climate, far northern climate, that was the equivalent of only 5.2 years of operational emissions, even at passive house level. Like, so it's dwarfed by the operational emissions still. Like, we still got to focus on energy. As excited as we are, and I am too, about biogenic products, we need to also always remember that it starts with how we use the buildings, because that's cumulative. So then we'd add that in. B6 is the module that we use to measure operational energy. So at passive house performance, at 60 years, which is the boundary of this measurement, it was still over 50%, even with a super low energy building. You can see how that deduction gets smaller and smaller each time. You know, I have some colleagues around the country who's like, oh, but Tim, you got to make sure you're understanding that the emissions are going to get devalued because the grid's decarbonizing. I'm like, okay, all right, I won't name names, but I'll do that. I'll put a 3% compounding deduction on the emissions from B6. It's still over a third at 60 years, still over a third. And this is a passive house, mind you. If I do all those things and do a conventional building, normal amount of energy use, 84%. So please don't get distracted by how excited everyone is about zero embodied emissions. We will get there at some point. It's important work. I'm part of that work nationally, part of that work with the White House, but it's a very small portion of the overall impact of the building. And that's even before we start looking at more advanced things like MEP and refrigerants. We started measuring that too. And so in this building, I did that as well. And once I add in MEP and refrigerants in a normal, for a normal building, again, just let's assume passive house level energy performance, but the refrigerant system, the heating and cooling system is in a normal layout, normal distribution. That leads to a certain amount of MEP. That was over a quarter of the pie, and all of a sudden that typical boundary, which is just the assemblies, was only 50% of it. The rest of it was operations, refrigerant, and MEP. So the mechanical engineer and I had this great idea, like, could we use less stuff with the MEP system? And he's like, do you think I could get a custom coil, custom refrigerant coil, and just shove it in the ERV? And I was like, I don't know, call Ventacity, who was making the ERV for us, the passive house certified ERV, and ask them if it'll fit. It did fit. We got the custom coil designed. For about 3 months, the guy who's not pictured here, you can see his arm, HVAC installer, complained. This guy, Dave Harris, who was our site super, did not complain. And he's like, some days, like, let's just all go on the roof and see if we can stuff this thing in there. So we just took the coil and stuffed it in. And he said, look, see, it fits. And then that allowed us to put the condenser right next to the ERV and reduce the volume of refrigerant by 80%. So we did passive house to refrigerant, right? 80% reduction in the quantity, which meant that we could chunk this whole section out almost. That also reduced our mechanical system, because all of a sudden we were delivering heating through our ventilation ductwork for the whole building. So we got rid of an entire set of ductwork, which took about a third of the mechanical emissions out as well. And so this is the kind of thinking that I'm like trying to kind of introduce you to, is like, how do you just find pathways to use less stuff? We were able to pay back the total emissions in 63 years of overproduction of energy. If we exclude module D and just assume that we don't know what's going to happen, that's 45 years. I like to say if a building's truly carbon positive, it needs to do it within its usable lifespan. And so that's going to vary by typology, but a dorm building on a college campus, we'd expect to be a 100-year building. So we feel good that this is a building that's actually reducing emissions over its life. You know, if we didn't have passive house, we couldn't fit that PV on the roof. It would take 3 roofs in order to do it. The reason that's important is that we can't count on just always being able to use other land for our renewables, whether it's PV or not, because eventually that's out of our control. We always want to see a pathway on the building. Again, if it was national average conventional assembly, that would never pay back on the building, impossible. And just leave you with some last pictures. It's also been a good test case for, this building's not open yet, it actually opens next week. So I don't have any pretty photos yet, but like, Ways to finish CLT in mass timber, that's all new. Like, how do you do that? You know, we have different examples in this building, some places where we just drywall painted it, some locations where we left it raw, some locations where we clear coated it or added finishes to it. But it is about normalizing a different aesthetic. You know, again, they haven't moved in yet. It's a very different aesthetic than a normal building. And just some photos of the exterior as we leave. We did benchmark this. Oh, it's way behind. We did benchmark this in our framework, and it did really well in all categories except for protected water cycle. And that had a lot to do with the town not allowing us to treat our wastewater on site. But it's interesting always to measure it and see how things work out. I'm just going to leave you with this last quote. The problems of the world are increasingly complex, but the solutions remain embarrassingly simple. I have some time for questions. I'm really happy that you had me here today. Thank you. Apparently, somebody might monitor the Zoom.
I'm working on the project right now. We're using CLT materials. So I have a lot of questions that I probably will ask you later. But where are you getting your lumber for your CLT panels? What I discovered that majority of good lumber for CLT panels come from Central Europe.
Yep.
So in your model, do you include all this emission and everything that takes to transport your wood from Europe to United States?
Absolutely. Yeah, we do. Yeah. So we kind of like know enough about how to customize the way we manage our LCAs, our life cycle assessments, to make adjustments if we see that it's off. So we'll often custom enter the A4, which is transportation, because a lot of times that's measured wrong. And that takes kind of going into the spreadsheets that get generated from those programs and not just looking at the reports. But yeah, right now it's about 4 times the emissions to get it from Europe and get it from Quebec. But the Nordic is the company in Quebec that most people use. It's the only one that makes CLT. They have a 2-year wait right now. So sometimes you're stuck based on availability at the moment. We'd love it to be more local, but we do measure it. Yeah, absolutely.
Just to say, a while back, I did a study with passive house windows versus domestic windows. And I called Pella and Anderson and Marvin and did the carbon footprint of trucking to a ship and a ship to the US and then trucking to the US versus trucking from Minnesota or wherever the other ones were coming from. And the trucking is so much more expensive than the ship in terms of its carbon footprint that they were almost identical.
Yeah.
So just there's always surprises in this whole system. I've known you since GoLogic and Passive House, you know, some of the first conferences and stuff, and always I'm, you know, impressed in where you're going. You kind of leapt over the retrofit thing that you mentioned, and that is sort of the big bugaboo. Like, so I just like you to expand a little bit on your retrofit thinking and strategies. Yeah,
I mean, the retrofit obviously is a hot topic now. It's tough for us because that's not our area of expertise, retrofits. We would like to offer through OPAL Build retrofit components if we could. And we are active with grant funding to try to allow for the potential for wood fiber insulation to be part of retrofit solutions. So we're trying to partner down the road with EFIS companies that can apply coatings to wood fiber. It's a product that's offered in Europe already. Like if you go to Stowe's German website, you can get Steica wood fiber as a substrate for EFIS. You can't get that in the US, but that's going to take funding and training between the two companies, which we're working on. As an architect, it's really not my area of expertise. I have colleagues that it is their area of expertise, and we'd usually try to steer people in that direction. Yeah, that's OPAL Build. They make that as a component. So the way that works is if you do digital modeling of facades and we can get the window sizes, we can sell and ship essentially a ring of we're probably going to be using CLT to do it because it's more stable. With a window already installed, that's the exact depth of the insulation that would fill the retrofit on the outside, so that a contractor wouldn't need to completely demolish an exterior wall to super insulate it. They could do it on top of whatever sheathing exists after the siding's removed. That was the idea for that. We've been approached by a few developers to offer the product, but the projects are still kind of early stages of development, and most of them are seeking funding through DOE grants in order to do a biogenic retrofit and avoid using foam. And most of them are in Massachusetts just because of how aggressive the energy code is. So it's like subset of subset of subset still. We're trying to get further along. And a lot of that work's done in collaboration with Rocky Mountain Institute because they've been leading the way on that. You know, they had a really great white paper, February 2023, about the potential for biogenics and retrofits. I'd encourage people to get it on their website. It's a good read about what's available and what's possible. Sorry, took a journey there. But yeah.
Hi, thanks for coming. I have two questions, one self-interested and one more abstract. Are wood insulation products recognized by UL assemblies and things like that? Is it a locally or a universally approved and available product?
Okay, what's the other question?
And then why Belfast, Maine?
Oh, geez.
Yeah, okay.
All right.
I'll take them off you.
So I'll answer Belfast, Maine first. It's kind of random. One of my business partners happened to end up in Belfast because his wife was doing her residency there, and on his way back to New York from Germany, didn't leave. And I grew up in Maine. My third partner, his wife had connections to Maine. We came back to join Matt there. And we kind of like it because we can kind of do what we want. There's no, it's like the northern frontier, I say. Like you can kind of just mess around and find out what happens. As far as the wood fiber, so yeah, part of the build out and kind of the product adoption and rollout of the product is testing, right? So there's an entire, Timber HP dwarfs the other two companies in employees now, because it turns out you need a lot of people to run a factory, and you need people testing products, and you need salesmen and all the salespeople and all that. And so it's its own deal that we are minority shareholders in. We're not running the day-to-day. You know, Matt, of the three of us, he's more interested in that, so he does that. Yeah, there's an entire testing wing that's doing all the UL testing. There's also, over time, going to be an NFPA 285 product. Right now, obviously, we're limited in height that we can use the rigid. And that product will come later, but we want to get the first product out. Basically, because we see this, especially and it's maybe not so much here, but when we get into climate zone 6, especially with IECC 2021 and beyond, there's a requirement for continuous rigid. And so there's low-hanging fruit there that isn't served by like zip R board or anything. It's not thick enough in 6. So if it's on the shelves, we'll worry about the 285 later. So that's the goal, but it takes time, all that. Yeah.
Yeah. All right, thanks. So as we wrap up here, do a little intro of our sponsor, one of our sponsors, One Click LCA. They, as a silver sponsor, they're Helsinki-based tech company that is focused on decarbonizing construction and manufacturing with world-leading, easy-to-use automated lifecycle assessment software. One Click LCA enables architects, designers, and engineers to calculate and remove the environmental impacts of building infrastructure and renovation projects. It also enables manufacturers to generate and publish third-party verified EPDs and assessment of circularity, life cycle cost, and soon biodiversity. One Click LCA is used in over 170 countries, and its decarbonization platform includes a unique global database of over 200,000 LCA data sets. It supports 80+ standards and certifications, including LEED, BREEAM, GRESB, and other national regulations. It was founded in Finland in 2001 and has a team of over 175 people. You can learn more at www.oneclicklca.com or by contacting Spencer Jarrett, who is a LCA and EPD consultant with One Click LCA, who is joining us virtually today. So thanks for joining, Spencer. And then I'll call up Rob Fleming to talk about this.
So, hey, everybody. Rob Fleming here, past president of Philadelphia AIA and currently working at the University of Pennsylvania. What an amazing lecture, Tim. This is why we're here at the AIA, and the work that the Committee on the Environment is doing is spectacular. Congratulations to Roshni and Catherine and the whole team for putting this together. It was really inspirational. As you can see on the slide up here, I'm also working on Meadows Level 1 transformation of paradigms. And I believe that higher ed now has to go through its own period of rethinking how it teaches, how it charges, and how it awards credit. And so I welcome all of you to look at the courses that are coming up here in the next couple months, and then we'll be launching our full program in Design for Sustainability in June. I will be around afterwards for anybody who has questions, and happy to talk to you about how higher education can do a better job for our profession. Thank you so much.
A plug for our committee here at AI Philly. We meet third Thursdays of the month virtually for 8 to 9 a.m. There's a QR code that you can click on, or you can talk to us after, and we can get you signed up. We're always looking for volunteers and enthusiastic people to join us. And then I'll leave it to Roshni to talk about some upcoming events and to wrap it up. Thanks.
We have a zero waste subcommittee April meeting coming up, and we have Farron Savitz who will be presenting with us. We are focusing on reducing cardboard waste as not getting commingled with other waste, and we'll be talking about specifications. And as part of the 2030 working group series, Low Carbon Assemblies, we have an exhibit from June 1st to 30th based on the publication by OPAL Architects. The publication is called Manual of Biogenic House Sections, and it makes a compelling argument on how we can reduce embodied carbon using plant and earth-based materials. And finally, I would like to say thank you to 12th Street Catering and our bartender, Derek, and also to AIA Philadelphia team, Rebecca, Daphne, Jelani, Julie, and Jordan. We have been going back and forth on planning the logistics, and also to the entire AIA Philadelphia team. I'd also like to thank Tim for coming to Philadelphia, for sharing his knowledge and spending a day with us. And I would like to give a shout out to the 2030 working group team, Kiran Kennedy, Shibe, Buddy, Cassie, David, Daniel, and Catherine. Thank you all for joining us today. I'll keep you posted on the upcoming 2030 events. Thank you. Tim, if you don't mind, we would like to take a group photo with you. And if folks want to please join for the photo, please come to the dais.
We've done FIAS before, sometimes. Honestly, we don't certify much anymore. A lot of people, it's like enough to know that it's working. They don't want to pay for it.
Right.
They don't need the plaque.
Passive House inspired and
Very
verified.
inspiring.
Yeah.
Thanks for taking me. Yeah, that's great.
It was my pleasure.